I wanted to work through a solution for question number 6 from chapter 14 homework, and this is part 2. So we're given the following information about the pH of a solution. The solution has a concentration of 0.085 molar and a pH of 2.68. Determine the value of the dissociation constant for this acid. And to do that, we need some concentrations first. We know pH, but we know that Ka equals the concentration of hydronium times the concentration of the conjugate base all over the concentration of the parent acid at equilibrium. We know the initial concentration of the parent acid, but we need to find my equilibrium concentration. I also need to find my concentration of hydronium and the concentration of the conjugate base to be able to find my acid dissociation constant. And fortunately for us, we can do that from the pH because we know that hydronium ion concentration equals 10 to the negative pH. I can take that pH value and use that to find hydronium, and that can go in this expression. And once I know hydronium, I'll also know the concentration of the conjugate base because they're going to be formed in this 1-to-1 ratio. For every acid that dissociates, we're going to get 1 hydronium and 1 conjugate base. So because we know the concentration of hydronium, we'll automatically know the concentration of the conjugate base as well. So hydronium equals 10 to the negative 2.68. My hydronium concentration equals 0.002089. And so for the rest of this calculation, we're going to use 0.0021 as my hydronium concentration, right? Which also equals my concentration of the conjugate base at equilibrium. So with that simple calculation, now we can get started in filling out that data table on the next slide. So here's the table, the ICE table that they ask you to fill out for this calculation. And a few things first, right? We never incorporate the concentration of a liquid or a solid. So for water, we see that water is a liquid. We're going to take this icon and we're going to just fill in that for water because that does not show up in our expression at all. It doesn't show up in our calculation at all. We know our initial concentration of the acid is 0.0850, and our initial concentration of hydronium is 0. The initial concentration of our conjugate base is 0. And some of you are setting up the table in terms of X, which is a good place to start. Here they're asking for us for concentrations. They want to know what is the concentration. So not to fill out the table in terms of X, rather, but fill out the table in terms of what are the actual concentrations and the changes in concentration. Well, we know at equilibrium, we have this pH that corresponds to a concentration of 0.0021 molar hydronium and the conjugate base. So we can plug that in. We know at equilibrium, I'm going to have 0.0021. So we're going to take this value right here and plug that in, right? 2.1 times 10 to the minus 3. And that also has to be our change because we started at a 0 for our initial concentration. So that would go there. This would go there. And for our change for our initial concentration, right, we're going to subtract that amount. So minus 2.1 times 10 to the minus 3. We subtract that, and our equilibrium concentration should be approximately 2.0829 for this equilibrium, for this acid, under these concentrations. Now we have an equilibrium concentration for everything in the reaction. We can finally calculate the Ka value for this acid. So for the Ka, we know that the Ka is equal to the concentration of hydronium times the concentration of my conjugate base all over the equilibrium concentration of my acid. We know that equilibrium concentration was 0.0829, so that goes down there. And from the pH, we know that our equilibrium concentration of hydronium was 2.1 times 10 to the minus 3. That was also our concentration of the conjugate base, 2.1 times 10 to the minus 3. So square that, multiplying those two together, right? And we divide by the equilibrium concentration of the parent acid. And we should get something like 5.3, yeah, right down here, 5.3 times 10 to the minus 5. So hopefully that helps with the ICE table, and hopefully it helps to see what they were asking for. As I said, many of the students filled this out in terms of X, and you filled it out correctly in terms of X, but they were just looking for what were the concentrations of each of those species in that equilibrium. So again, this was question 6 from chapter 14, part 2, homework. Let me know if you have any other questions, and I'll be happy to work through a solution for you.